Okay, so we've already learned that we know that the derivative of e to the x is going to be e to the x. And we also know that the derivative of ln of x is going to be 1 over x. So those are two things that are known already. So now we're going to go and we're going to say, all right, well, what if my base isn't e? What if I have a different number there? So remember that e is technically, if you type e into your calculator, you come out with 2.718 something, right? So e is technically a number. So what happens if I have a 2 there? What happens if I have a 4 there? Those rules don't apply the same way. Same thing, ln of x. An ln is technically a log base e. So what happens if I have a different number there? That's what we're going to go through right now. So a to the x power. So the difference between this and the power rule is that we have our x is up in the exponent. So the variable is in the exponent, okay? So we can't use our normal power rule. So we're going to use the rule that we're going to follow for the derivative of an exponential function. So no matter what the base is, okay, if it's a to the x, it's going to stay the same, kind of like our e to the x did, but the only thing you have to do now is you have to multiply it by the natural log of the base, okay? Multiply by the ln of the base in your original question, okay? So that's what we're going to practice today. We're going to practice finding these derivatives. So if I have y equals 7x, I'm going to find the derivative, okay? I know it's going to stay the same, kind of like e to the x, but then I just have to multiply by the ln, or the natural log, of the base, okay? Now, you might see it written this way, ln of 7 times 7 to the x. They're both the same thing, okay? All right, the second one, I'm going to use y prime this time, same thing. So it's going to stay 5 to the x, and then I'm just going to multiply by the natural log of 5 this time. So if I want to flip those around, I can. Natural log of 5, natural log of 5 times 5 to the x, that works also. Okay, now this one, this negative is going to stay out in the front because that's kind of like a -1 times 3 to the x. So we want to keep that negative out in the front. So let's use dy dx this time. So I'm going to have negative 3 to the x and then my natural log of 3. So if I want to flip those around, I can. And actually in that case, I'm going to want to put the negative in the front. Okay, now let's use the same rule for e to the x. So e to the x is going to stay e to the x, and then I have to multiply it by the natural log of e, which we all know that the natural log of e is going to cancel out because that's going to be equal to 1. That's basically asking you e to what power will give you e, and it's got to be 1. Okay, so that's why, using our rules, e to the x is still going to have a derivative of e to the x. Okay, so anytime you do the derivative of an exponential function, you should get something that looks like that. Now, we're going to throw in some other rules here because, as you know, we never just do one rule. So here, we now have a composition of functions. So I have this function right here that's kind of like my inner function. Okay, so remember when we do our chain rule, so we have an inner function, and then I have an outer function that's kind of like 4 to the something, right? And then I have 2x as my inner. So I want to do the derivative of my outer function. So if I do f prime of x, okay, the derivative of 4 to the something is going to be 4 to the something times the ln of 4, okay? And remember, that something up here that was ignored is going to stay as 2x. Okay, so all I did was I did the derivative of 4 to the 2x, just like I did before. But now, since my exponent is not just an x value, I have to also multiply by the derivative of 2x So if I do dy dx, that's going to be 2. Okay? And that's your final answer there. Now, I cannot multiply these 4 and this 2 because it's ln of, so that's stuck together. So really, there's not a ton you can do to simplify this. You can reorder it if you want. 2 times the ln of 4 times 4 to the 2x. Okay, but remember, AP-wise, you can leave everything unsimplified. Okay. Again, we have, I'm going to kind of cross this out and say that my inner function is going to be x squared minus x. So we're going to ignore that for right now. My outer function is 7 to the squiggle line, whatever that is. So when I go and I find my derivative, 7 to the something is going to be 7 to the something times ln of 7. We know that. And my something up in the top is going to stay as x squared minus x. So we're still doing that outside derivative the exact same way. Now I got to figure out, all right, well, dy dx here is going to be 2x minus 1, right? So I need to multiply this by 2x minus 1. Now, what I wrote there is technically incorrect. Multiplying, this right here is multiplying only by the 2x. Since I want it to multiply by the whole thing, I have to make sure that I put parentheses. So if I reorder this a little bit, there's nothing I can do to simplify. I'm just going to rewrite it as 2x minus 1 times the natural log of 7 times 7 to the x squared minus x. So there's nothing you can do there to really make it more simple. I just like putting my thing with the exponent. I like putting that at the end always. Okay? All right, derivatives of logarithmic functions. So we already talked about the fact that we know that the derivative of ln of x is going to be 1 over x. Okay? So what happens if this isn't an e? Well, whatever this base is, it's still going to be 1 over x. We now just have to add in this extra little ln of a. Now notice this is a log and this is an ln. That's correct. It's supposed to stay as an ln. Okay? And you're just adding that into the denominator there. So if I have log base 4 of x, then my derivative is going to be 1 over x ln of 4. Okay? The derivative of this one is going to be 1 over x ln of 2. The derivative of this one is going to be 1 over x ln of 7. And then ln of x, if I do the derivative of that, remember this is really a base of e, that's going to be 1 over x ln of e. And we just went over a second ago that ln of e is actually just 1. So that's where the 1 over x comes from when we talk about natural logs. So the only extra thing you have to add here, anytime you do the derivative of a log function, it is 1 over that inside part, but you have to make sure that you multiply by the natural log of the base in the denominator. So we want to multiply the denominator by ln of the base. Okay, so that's the only extra thing we have to do. So logs and natural logs are very similar. They're still going to come out to be 1 over x. It's just that when you have a log, you have to throw in that extra ln of a in the denominator. So let's do a couple examples. Y equals log base 4 of negative 7x. So I'm going to do dy dx. So notice here I kind of have an inner and an outer again. Okay, I got this little inner thing here, which I'm going to lightly cross out. We're going to ignore the inside for right now. Okay, if I do the derivative of log base 4 of x, I know it's 1 over the inside. And then I know that now I have to do ln of 4, right? So up here, my inside was always just x. Down here, my inside is actually negative 7x. So it's always 1 over the inside, basically, is what you can think of it as. right? So my inside was negative 7x. So if I do the derivative of negative 7x, I'm going to just get negative 7. So now I need to multiply this outside by negative 7. Okay? So let's rewrite that. I'm going to get negative 7 over negative 7x ln of x. Right? So now, ln of 4, my bad. Ln of 4. Now I can actually cancel out those negative 7s. So it's really 1 over x ln of 4. Okay. All right, next one. 1 over the inside. So my inside function again is this thing. So 1 over the inside, which is going to be x squared plus x. And then I have to multiply by the natural log of the base. Okay. And that's our log derivative. Now I just need to, because I had a chain rule problem here, now I just need to multiply by the derivative of x squared plus x. So the derivative of x squared plus x is going to be 2x plus 1. Okay. And then we can simplify 2x plus 1 over x squared plus x ln of 2. Remember, that's not correct the way I wrote it. These parentheses are super important because that whole thing is being multiplied by the natural log of 2, not just the x. So that is your derivative. Okay? So just a little review. The derivative of an exponential function is going to stay exactly the same, and then you just have to multiply by the derivative of the base. Okay, so that's the little extra thing that's thrown in there that's different from e to the x. Okay. Chain rule, you still have to multiply by the derivative of the inside after you do the derivative. And then for the derivative of a logarithmic function, if it's not a natural log, it's still going to be 1 over x. You just have to add that natural log of a into your denominator. Okay. So we'll do some practice with this in class, but that gives you a nice little starting point with a couple examples so that we can build off of them.